Hello, my dear children. I'm Pradeep sir, discussing physics paper. Hope all of you are so happy to get an easy physics paper this year with 19 questions from first year and 26 from second year. Let us go through the questions. The first one is 136 one. Guitar string, two strings A and B, same material, slightly out of tune, produce beats of frequency 6 Hz. Beat frequency, you know, is the difference of frequencies between two frequencies. When tension in the string B is slightly decreased, the beat frequency increases to 7 Hz. Frequency of A is 530 Hz, then the original frequency of B is. That means the beat frequency is the difference of frequencies, and also you know the frequency is directly proportional to square root of tension in the wire. So when tension is decreased, frequency also will be decreased. For the beginning, the frequency of A is mentioned to be 530 Hz. Okay, then that of B must have a difference of 6 Hz, that is either 524 Hz or 536 Hz. So either 524 or 536 should be the answer. Both are there in options. Okay. Now the second part of the question says that the frequency, beat frequency increases to 7 Hz when the tension is decreased slightly. When the tension is decreased, the frequency is necessarily decreased, so that the frequency when decreases, if our answer is 524 Hz, say the frequency of B when decreases, it can be 523, 522, etc., etc. There, this 523 can create a difference of 7 Hz with 530, because 523 plus 7 only is 530. That is why our answer should be 524, not 536. Why not 536? If it is 536, when the tension is decreased, 536, it should be lesser than that. That means the reading should be 535, 534, neither 535 nor 534 or any readings coming like this will never make a difference of 7 Hz with 530. So our answer should be the third option. Okay, we move to the next one, 137. It's about a capacitance of parallel plate capacitor with air as dielectric medium, capacity 6 microfarad, with the introduction of a dielectric medium in between the plates of the capacitor. The capacity has become 30 microfarad. What is the permittivity of the medium? The students might have made, several students might have made mistakes, because the capacity, when the medium is replacing air, the capacity C dash is equal to K times C. K is the dielectric constant. Dielectric constant should be then 5. K equal to 5, because C dash is given to be 30, C is given to be 6, then K is equal to 30 divided by 6, that is 5. K is the dielectric constant. That implies epsilon R, dielectric constant or relative permittivity, is equal to 5. It is relative permittivity, that is which is 5. Then that also is there in option, but that is not the answer, because the asked one is permittivity of the medium. Permittivity epsilon is equal to epsilon 0 epsilon R. That means epsilon 0 value is also given there, 8.85 into 10 power minus 12 multiplied by 5. So the answer should be 8.85 into 5 into 10 power minus 12. Then the answer should be the fourth one. Should be the answer, right? Then the answer is the fourth one. Then 138 one. 138. The phase difference between displacement and acceleration of particle in SHM. We know in SHM, the equation for the acceleration is A is equal to minus omega square x, where A and x are acceleration and displacement. The negative sign indicates that the phase difference between acceleration and displacement is 180 degree. Then answer is pi radian. Answer must be pi radian. So pi radian is the right answer. Okay, let us move to the next one, 139th one. Question number 139. In 139, the light of intensity 1.5 times the threshold frequency is incident on a photosensitive material. What will be the photoelectric current if the frequency is halved? If the frequency is halved and intensity doubled. It's very important one. When frequency is halved, okay, the incident energy goes below the work function. That means incident frequency goes below the threshold frequency. When incident frequency is less than threshold frequency, no photo emission takes place. That is why there will not be any photocurrent. So our answer should be 0. Okay, that means it does not have any intensity dependence. As the incident frequency is halved, initially the frequency, light of frequency 1.5 times the threshold frequency incident. That means when frequency is halved, that means the incident frequency would become 0.75 times the incident, 0.75 times the threshold frequency. That means the photo emission is not taking place, as the Einstein's photoelectric equation will not be justifiable here. Okay, then the answer must be the first option, 0. Next one, 140. A spherical conductor of radius 10 centimeter has a charge of 3.2 10 power minus 7 coulomb distributed uniformly. The electric field at distance 15 centimeter from the center. We know electric field intensity due to a point charge is given by E is equal to 1 by 4 pi epsilon 0 Q by R square. All that you know, I substitute 9 into 10 power 9 into charge is 3.2 into 10 power minus 7 divided by 15 into 10 power minus 2 whole square, distance square, that is 225 into 10 power minus 4. Approximations are necessarily done. 9 into 3 is 27. So this 27 divided by 225 will be nearly 0.1 something, let it go, into 10 power. This minus 4 and minus 7 cancels and minus 3 comes in the numerator and plus 6 comes in the numerator. That means 0.1 into 10 raised to 6, 0.1 into 10 raised to 6, that is 1 point something into 10 raised to 5 should be the answer. Then the answer, right answer is 1.28 into 10 raised to 5, right? Next one, 141. Very simple and directly asked from NCERT text, very clear. Variation of resistivity from with absolute temperature. The graph shown for copper, readily it is given in textbook, and that is the fourth option is the correct answer. Next one, 142. For transistor action, which of the following statement is correct? Many questions have been asked from chapter solids and semiconductor devices. Here one is there. The base region must be very thin and lightly doped. Very simple concept. Every children should know that the answer is the first option. Base is very thin and lightly doped. Okay, the next one, 143. The average thermal energy, monatomic gas have got 3 degrees of freedom. So there are 3 translational degrees of freedom. That means as per law of equipartition of energy, it is 3 into half kBT. So average thermal energy per mole is 3 by 2 kBT. That means answer must be the third option, right? Next one, 144. In a certain region of space with volume 0.2 meter cube, the electric potential is found to be 5 volt throughout. The magnitude of electric field in this region is, we have learned that in some volume space, if potential is a constant, the electric field there necessarily be 0. So the answer must be the second option. Okay, no need of any workout with this numerical given, because if a conductor, for example, if a conductor is a spherical conductor, you know, if charged, it is at constant potential. The spherical solid conductor, metallic conductor has a constant potential surface and also inside, where there is no electric field inside the conductor. Okay, that we have learned as one of the important properties of electrostatic properties of a good conductor. Okay, next one, 145. Is that about a capillarity, concept of capillarity? Very simple and interesting one. Many times we have answered similar one. The mass of water in capillary is 5. The other capillary of twice the radius use, what happens to the mass what is ascending through the capillary tube due to capillarity. Everyone knows the ascent formula for capillarity, that is H is equal to 2S cos theta by R rho G, where H proportional 1 by R. Also, we know the mass of water rising through the capillary tube due to capillarity, mass is equal to volume multiplied by density. Volume is, as it is a narrow bored tube, volume is that of a cylinder, that is pi r square h into rho. So, m is proportional to r square h, but h is proportional to 1 by r. So, m proportional to r square times 1 by r, 1 r gets cancelled. So, m proportional r. What happened to r here? R has been doubled. The first capillary possessed a radius r, the second one possessed a radius 2r. When radius doubled, mass also should have been doubled. Initial mass is 5 gram, the new mass should be double that means 10 gram. So, the answer is the fourth one. Next one, 146. The two particles of masses 5 kg and 10 kg respectively attached to two ends of a rigid rod of length 1 meter. The center of mass, we know the center of mass of two particle system will be concentrated towards the heavier one. The total length is 1 meter. In C frame, we know that M1 R1 is equal to M2 R2, that means M proportional to 1 by R. So, the total distance is given 1 meter, that 1 meter distance is divided in the inverse ratio of masses, that is you divide 1 meter into the inverse ratio of these masses, that is 5 and 10. 5 and 10 is 1:2, so you divide into 2:1, so 1 into 2 by 3, 1 into 1 by 3. That means this one will be 67 centimeter and this one will be 33 centimeter. That means 67 centimeter from the heavier one, 10 kilogram, and 33 centimeter from the lighter one, 5 kilogram. Here asked about the distance about heavier one, that means particle near distance of 67 centimeter. It should be from 67 centimeter, center of mass of system from 5 kilogram. From 5 kilogram it should be 67, and the center of mass will be close to the heavier one, that is 10 kilogram. From 10 kilogram it must be 33 centimeter, right? Then our answer should be the fourth one, 67. Okay, it should not be 33, it is 33 from 10 kilogram and 67 from 5 kilogram, right? Next one, 147. Two cylinders A and B of equal capacity are connected to each other by a stopcock. A container has ideal gas, standard pressure and temperature. B is completely evacuated. Okay, A has gas. When the stopper is removed, the process is. In this process, here the gas surges into the other one. In this process, there is no work done because there is no friction, no external agency. Here, there is no thermal transfer between the system and surroundings. As there is no work done, this should be a free expansion. In free expansion, students, we have learned that change in internal energy is 0. In free expansion, change in internal energy is 0. In the process in which there is no change in internal energy should be the isothermal process. Okay. No other possibilities are there, but you know, students, that in isothermal process also there can be change in internal energy if that isothermal process is associated with a change of state. Here, nothing mentioned here. There is no change of state occurs during when melting or boiling. That is also isothermal, but there is a change of state. So there is an internal energy change, but nothing that, no question of that, because it is ideal gas. Okay, and there is no change of state mentioned. So the answer should be isothermal. Answer is second one, isothermal. 148. The energy required to break one bond of DNA is 10 power minus 20 joule. The value in electron volt. Very simple one. You can get the answer by converting 10 power minus 20 joule into electron volt. How to convert joule into electron volt? By dividing by 1.6 into 10 power minus 19. 1 by 1.6, you know, it is nearly 0.6. 1 by 1.6 nearly 0.6. Into 10 power minus 1 comes there, that is 0.06. Then our answer must be fourth one, 0.06. Okay, it's also directly given from textbook. Okay, we people, every time we people ask you to read textbook, this was the reason why we say that. 149. A ball is thrown vertically downward with velocity 20 meter per second from the top of a tower. It hits the ground after some time with velocity 80 meter per second. As it is in gravity, the constancy of acceleration due to gravity, you can use kinematic equations. Kinematic equations, when you can use what? V square minus u square equal to 2a, so that the height h is equal to v square minus u square divided by 2a. A is acceleration due to gravity g. That means v is 80, 80 square 6400 minus u 20, that is 400 divided by 20. That implies 6000 divided by 20 is nothing but 300 meters. Students, also, all the problems were very simple, also very simple way. We have never seen similar simple papers for NEET examinations before. Now 150. The energy equivalent of 0.5, another simple one, 0.5 gram of a substance is, okay, the energy E is equal to delta mg square from Einstein's mass energy equivalence, that is 0.5 into 10 power minus 3 should be there, into 3 into 10 raised to 8 whole square, that is 9 into 10 raised to 16. So it must be 4.5 into 10 power 13. The answer must be the third option. Okay, confusing options are there, they have set. So many students may have made mistakes. 151. The solids which have negative temperature coefficient of resistance are that insulators and semiconductors. Data given from NCERT. You can refer NCERT, it is mentioned in NCERT. Okay, for insulators and semiconductors, temperature coefficient of resistivity is negative. 152 is the next one. There, an electron is accelerated from rest through potential difference of V volt. De Broglie wavelength of electron is given, then the potential difference is. We have learned the formula, shortcut formula for finding de Broglie wavelength of electron from NCERT text itself. It is readily given that lambda is equal to de Broglie wavelength, lambda in nanometer is equal to 1.227 divided by square root of accelerating potential. So in this way, when you write the V, which is the potential difference applied in volts, and you use this equation, you will get the de Broglie wavelength in the units nanometer. Here the de Broglie wavelength itself in the unit of nanometer is given, that is 1.227 into 10 power minus 2. 1.227 into 10 power minus 2 nanometer is given, lambda in nanometer, that is equal to 1.227 divided by square root of V. 1.227 readily cancels. So root V is equal to 1 by 10 raised to minus 2, that means 100. So V must be 10 raised to 4, that is 10,000. So the answer must be the first option. Okay, next one is 153. 153 is from magnetism, moving charges and magnetism regarding solenoid. Solenoid here has turns per unit length, total number of turns 100 and the length is 50 centimeter. Current is 2.5 ampere. Magnetic field at the center of the solenoid. Everyone knows the formula for field at the center of solenoid as mu 0 Ni, where mu 0 is 4 pi multiplied by 10 power minus 7. Small letter n is the turns per unit length. That means total number of turns is 100 divided by length is 50 centimeter. Convert into meter. That means 1 by 2, half meter. That 2 will go to the numerator in calculation, into current is 2.5. Okay. Therefore, on calculation, you will get 100, 2.5 into 2, 500, 500 into 4 pi into 10 power minus 7. Okay, that is 20 into 10 raised to 2 pi into 10 raised to minus 7. That is 2 into, that implies 2 into pi into 10 raised to minus 4, that is 6.28 into 10 power minus 4. So answer must be the second option. Okay, 153 answer is the second option. 153 answer is the second option, right? 154th one is the next one. Ratio of contributions made by electric field and magnetic field components to the intensity of electromagnetic wave is. We know in transverse electromagnetic wave, the energy content is equally divided among electric field and magnetic field. That is why the answer is 1:1. Energy density is equally divided. That half epsilon 0 E RMS square is exactly equal to half B RMS square by mu 0. We have learned that energy densities are equally shared. 154, then answer must be 1:1. Third option is the right answer. 154 answer 1:1, third option. 155. Short electric dipole has dipole moment given potential due to dipole at some distance 0.6 meter at an angle 60 degree. What is the potential? We know the potential due to short dipole as potential V is equal to 1 by 4 pi epsilon 0 P cos theta by R square. 1 by 4 pi epsilon 0 is 9 into 10 to the power 9. P is the dipole moment, that is 16 multiplied by 10 power minus 9. Now cos 60 is 1 by 2. So 1 by 4 pi epsilon 0 P cos theta divided by R square. R is 0.6, so it can be written as 0.36. Okay, here this 9 and 0.36 can be cancelled. Here you can write 10 power minus 2. Here it comes a 4. This 4 and 2 becomes 8. 8 and 16 cancels and 2 comes in the numerator. Then the answer will be 2 into. Here 10 power 9 and minus 9 also cancel, students. Here 2 into 10 power 2. So it must be 200. 155 answer must be 200. So the third option must be the right answer. Third option is the right answer, 200. Okay, I have calculated, and calculations also were very simple for all problems. 156 is the next one. Iron rod of susceptibility 599 is subjected to magnetizing field of 1200 ampere per meter. Permeability of the material of the rod. We know, we have learned that the susceptibility chi is equal to mu r minus 1. So mu r is equal to 1 plus chi, that is 599 plus 1, so 600. Mu r is 600. Then the permeability mu is nothing but mu naught mu r. Mu naught is 4 pi into 10 power minus 7 multiplied by 600. Then the answer should be 600 into 4 is 2400 pi multiplied by 10 power minus 7. That means 2.4 pi. 2.4 pi into 10 power 2.4 pi into 10 power minus 4. 2.4 pi into 10 power minus 4. Answer should be the second option, right? Answer is second option. Second option is the correct answer. 157 is the next one. A body weighs 72 Newton on the surface of Earth. What is the gravitational force on it when the height is equal to half the radius of Earth? Okay. We know the formula for acceleration due to gravity at an altitude. G dash is equal to G into R divided by R plus H whole square. Okay, for multiplying by M you get the weight. Okay, that means mg dash by mg is equal to R divided by R plus H whole square. H is given R by 2. H is given R by 2. That means here it becomes denominator 1 plus 1 by 2, 3 by 2. So R cancels and it becomes 2 by 3 square. You do not forget square. That means 4 by 9. 4 by 9. That is mg dash equal to mg into 4 by 9. That is mg is given 72 into 4 by 9. That is answer 32. So third option is the right answer. 32 Newton is the right, must be the right answer for 157. Next one is 158. A screw gauge has least count of 0.01 millimeter and there are 50 divisions in circular scale. Pitch of the screw, very simple one. Pitch is equal to, least count is equal to pitch divided by number of divisions. Number of divisions on circular scale. Pitch divided by number of divisions on circular scale. That means pitch is equal to least count multiplied by, least count is 0.01 millimeter multiplied by number of divisions on circular scale 50. So 50 into 0.01, that must be 0.5. Everyone must have made it correct. 158, fourth option is the right answer. 159. The quantities of heat required to rise the temperature of two solid copper spheres of radii R1 and R2. R1 is equal to 1.5 times R2 through 1 Kelvin are in the ratio. We know heat which is used for raising the temperature of a substance, which is nothing but the sensible heat, is given by H is equal to ms delta theta. Here it is given that both the bodies are heated through same ranges changes in temperature, and both the bodies are of same material, so specific heat also do same. H is proportional to m. Okay, but mass is equal to volume into density. Volume is that of a sphere. Volume of a sphere is 4 by 3 pi r cube. That means H proportional to r cube. Therefore, H1 by H2 is equal to R1 by R2 whole cube. R1 by R2 is 1.5, that is 3 by 2, but we need cube. Listen, 3 by 2 is also there. For many students may have made by mistake, they must have forgotten to write the cube there. So it must be 3 cube is 27, 2 cube is 8, then the answer is second option is the right answer. 159, second option is the right answer. Now go to the next one, 160. 160, two bodies at Wood's machine. Acceleration of this system very clear, and it is well known to every student. It is known main body of NCERT, and also the back exercise it is there. We know the equation for acceleration. Acceleration of Wood's machine is equal to m1 minus m2 divided by m1 plus m2. That is 6 minus 4 by 6 plus 4 into g, that is 2 divided by 10 into g, that is g by 5. Answer fourth option. So 160 answer is g by 5, fourth option. Okay. 161 is the next one. Assume that light of wavelength 600 nanometer is coming from a star. The limit of resolution of telescope whose objective has diameter. Limit of resolution, which is the reciprocal of the resolving power, is nothing but limit of resolution is equal to 1.22 lambda divided by the diameter. Very simple substitution, 1.22 times wavelength is 600 nanometer. Don't forget that divided by capital D is 2. Here you cancel, this becomes 300. So 12 into 3 is 36. No other options start with 36. So we opt that 3.66 into 10 power minus 7 radian, no need of further calculations. Okay, 161 answer second one. Next one 162 is a readily available answer. Increase in the width of depletion region is only due to the reverse biasing. While with forward biasing, the reduction of the width happens, but with reverse biasing, the width of the depletion layer increases. That means reverse bias only. Answer is the third option. 162, third option. Now 163 is the next one. Light with average flux of 20 watt per centimeter square. You must take care while reading the units. Watt per centimeter square, carefully read, falls on a non-reflecting surface. That means that light absorbs fully. At normal incidence having surface area 20 centimeter square, energy received by the surface during the span of 1 minute is, we know the intensity is nothing but energy per area per time. So the energy is equal to IAT. Intensity, watt per centimeter square given must be the intensity, average flux. Students, you may not be aware of the different names of the physical quantities that the different question paper setters write in their own question papers, but you should be aware of different units. Watt per centimeter square is the unit of that intensity. Somewhere somebody has told average flux, that all names are there, but you do not confuse. I is nothing but intensity. Intensity is 20, but that is watt per centimeter square. Watt per centimeter square, convert that denominator centimeter square into meter square. That means 10 power minus 4 comes in denominator, so 10 power plus 4 should appear in numerator. Per centimeter square 20, so for meter square it should be 20 into 10 power 4. It should be bigger. Don't confuse while converting the units. Area 20 centimeter square, 10 power minus 4 into time. Time is 1, no, it should be in seconds. So 1 minute is converted into second, 60. Okay, then the answer should be, you can see the answer as fourth option, 24 into sorry, it's not the ratio, it's not the ratio, it should be the product into IAT. by mistake I wrote like that. Okay, sorry, IAT. What is area? Area is 20 into 10 power minus 4 into time is 60. So 6 into 4, 24. Readily answer is there. 6 into 4, 24. No other option. So answer is the fourth option. Next one. 164. Direct answer. Equation 1 by root 2 pi n d square. 1 by root 2 pi n d square. Third option must be the correct answer. Now 165. 40 microfarad capacitor is connected to 200 volt 50 hertz AC supply. RMS value, then IRMS. We know IRMS is equal to VRMS divided by XC, as it is a capacitive circuit only. XC is equal to 1 by omega C. Okay, that is XC equal to 1 by 2 pi FCC. Then VRMS divided by 1 by 2 pi FC, that means into 2 pi FC. That means IRMS is equal to VRMS is given 200 into 2 pi into frequency is 50 into 40 into 10 power minus 6. Okay, you calculate and you get 2.5 ampere. So the correct answer is the fourth option. Fourth option is the correct answer. Now you move to the next one, 166. 166 is regarding color code, current electricity. Many questions have been asked from this chapter. We should know the basics that B.B. Roy of Great Britain has a very good wife. B.B. R.O.Y. B.B. Roy of Great Britain has a very good wife. Let us count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this will be the number, and the next coming is the multiplier. Multiplier is 10 power 0, 10 power 1, 10 power 2, 10 power 3, like that, right? Next one is the tolerance. For gold 5%. Here mentioned gold, so 5% should be the answer. Three options are there. Okay, silver 10%, no color 20%, like that. Gold has 5% tolerance, so answer should contain 5%. Okay, anyway, here the first color is yellow. Let us see the yellow from here. Yellow happens to be here. That means yellow is 4. That is 4. The second color is violet. Violet happens to be here. That is 7. So 47. Okay, all options there. We have to choose the next one. Multiplier. What is the multiplier of brown? Multiplier of brown. Confusion, B and B. First one is black, second one is brown. So brown has a multiplier of 10 power 1. So into 10 power 1 ohm plus or minus 5% tolerance. Then our answer should be 470 ohm plus or minus 5% tolerance. Answer should be the very first option. First option is the right answer, right? Next one, 167. 167. A wire of length L, area A hanging from fixed support, length of wire changes to L1 when a mass M is suspended from the free end. The expression for Young's modulus is, you know, students, the question is asked from first year topic, properties of solids. Formula for Young's modulus is mgl by A into delta L. mgl by A delta L. Okay, here what is delta L? Delta L is the expanded length minus initial length. Expanded length is L1, initial length is L. So this should be the answer. That is mgl by A into L1 minus L. The first option is the answer for this simplest one. 167, first option. Next one, 168. For the logic gates from solids and semiconductors, digital part, gates, truth table is, okay, here many methods have been used, but the simplest one where everyone can follow can be used like this. If you give 1 and 1 as inputs, 1 and 1, let us give 1 and 1. This is a NOT gate, so here comes 0. This is another NOT gate, here comes 0. 0 and 0, this is a NOR gate. NOR means OR plus NOT. 0 OR means addition plus 0 plus 0 is 0 but not, so it becomes 1. So 0, 1, 1, 1 comes in two options. 1, 1, 1 comes in two options. 1, 1, 1 and 1, 1, 1. So either second one or third one is the right answer. Okay, how to choose that? For that we have to take the trial for 1 and 0. Then only we will get answer. 1 and 0. Let us try for 1 and 0 here. 1 and 0. Okay. Then 1 and 0. Here 1 comes, here 0 comes. 0, 1. 0 and 1 or 0 plus 1, 1. Not 0. So 1 and 0, 0 should be the answer. 1 and 0, 0 comes here. So second option is the right answer. Okay. Then next one is 169. 169 series LCR circuit, second year, chapter AC, connected to AC voltage source. When L is removed from circuit, phase difference between current and voltage is pi by 3. If C is removed, the phase angle becomes again pi by 3. From the impedance triangle that we have learned, if this angle is the phase angle and this be the reactance, this will be the resistance. So tan phi is equal to X divided by R. When L is removed from LCR, it has only C, so XC by R, and phi is given pi by 3, that means 60 degree. Tan 60 is nothing but root 3. Similarly, when when C is removed, it is again tan 60 is equal to XL by R. That means again root 3. So XC equal to XL is equal to R root 3. XC and XL both are equal. That means the series LCR circuit is in resonance. In resonance, we know the power factor. Power factor is 1 because the phase angle phi for series LCR circuit at resonance, phase angle is 0. So power factor cos phi is equal to 1. So the correct answer must be the fourth option. Fourth option is the correct answer. 170 is the next one. 170. Dimensions of stress. Very simple one. Dimensions of stress is equal to force by area. Force by area. Force is mLT raised to minus 2. Area L square. So L cancels. mL minus 1. mL minus 1 T minus 2. mL minus 1 T minus 2 is the right answer. 170 answer is first option. 171 is the next one. 171. A cylinder contains hydrogen gas at pressure 249 kilopascal, temperature 27 degrees Celsius. Its density is, universal gas constant R is given. Okay. The popular equation for ideal gas, PV is equal to nRT, where N is the number of moles, which can be expressed as actual mass divided by the molar mass, where this mass and volume whose ratio can be written as density, so that P is equal to mass by volume is density. So rho by m RT. From this you can easily calculate rho, which is MP divided by RT. M is the mass. Hydrogen is H2. That means its mass is 2, but that 2 gram convert into kilogram. Answer is in SI into 10 power minus 3. Don't forget to put that 2 into 10 power minus 3. Pressure is 249. I am writing 250 into 10 power 3 for approximation. 249 rounded to 250 into 10 power 3 because kilo is there, divided by universal constant is 8.3 into temperature is 27 change into Kelvin, that is 300. Okay. Then this 2 zeros cancels here. Here this 3 cancels and 10 appears there. 8 into 3 is 25. This 25 cancels, 1 10 appears there. 10 into 10 power minus 3 is 10 power minus 2. So 2 into 10 power minus 2, that is 0.2 should be 2 into 10 power minus 1. So 0.2. The answer should be 0.2, that is 171. Answer is the third option. Third option is the right answer, 171. Find the torque about the origin. The only one question asked from the rotational dynamics. Force 3J Newton acts on particle, position vector 2K. We know torque tau about some point is equal to R cross F. Okay, R has a unit vector K cap and F has a unit vector J cap. K cross J is nothing but minus I. So minus I, there is only one option. So no other choice other than minus 6 Newton meter. Torque is equal to force into displacement, that is 3 into 2, that is 6. Okay, in two ways it can be proved. Minus sign, no other options. Then answer is fourth option, 173. For which one of the following Bohr model is not valid? It's very important. Is valid, is not valid. Okay, Bohr model is not valid. Singly ionized neon atom, that itself is the correct answer, because for singly ionized neon, it is not valid. For Bohr model to be valid, that atom should be ionized to such a way that it should contain only one electron in the orbits. Okay, deuteron atom, that is possible. Deuteron means the nucleus of deuterium atom. Singly ionized helium, that is also hydrogenized, hydrogen-like, hydrogen atom, all that. But answer is 173, first option. 174, when uranium isotope, uranium 235, 92, bombarded with one neutron, it becomes krypton 36 and 89 plus 3 neutrons. Okay, what else releases as the byproduct? So we have to use the conservation of charge and conservation of mass. Let us first choose the conservation of mass, that is written on the top. You add the total number of nucleons on the left hand side, that is 235 plus 1, that is 236. You subtract from the right side mass. 89 plus not 1, 89 plus 3, because 3 neutrons are there. 1 neutron has mass 1, 3 neutron has 3. So 89 plus 3, it should be 92. So subtraction 4, then 4 and 1, 144. Mass 144 for only one option. Then the answer is second option. Okay, mass conservation, and hence if you want, you can use charge conservation also. Here no need. 175 is the next one. Taking into account significant figures, first chapter, first year, units and dimensions, only one question asked, and that is it. The value 9.99 meter minus 0.0099. In addition and in subtraction also, we use same rules. We have to see the minimum number of decimal places in each of that measurements. And the final answer should contain only retain as many number of decimal places which contained by the least precise measurement, which contained only minimum number of decimal places. Here the first measurement, this measurement contains 2 decimal places. The second measurement contains 4 decimal places. The final answer should contain only 2 decimal places. There is only one option where there are 2 decimal places, and that is the third one. So the right answer is the third option, 175, option 3. Next, 176. Brewster's angle IB, that's a nice one. IB for interface, any interface should be, we know the Brewster's law states that tan of angle, Brewster's angle, tan of Brewster's angle is equal to the refractive index. The refractive index of any medium varies between, refractive index is greater than 1 and is less than infinity. Refractive index varies between 1 and infinity. If refractive index is 1, IB should be 45. Okay, but refractive index other than vacuum, it should be greater than 1. So the angle should be greater than 45. So IB should be between 45 and 90, because the other angle should be tan 90, which is infinity. So for n values possibly between infinity and 1, the ranges of values possessed by the Brewster's angle should be between 45 and 90. Then the answer must be fourth option. 176, fourth option. 177. Charged particle having drift velocity given, electric field given. Everybody knows mobility mu is equal to drift velocity divided by electric field, nothing but 7.5 10 power minus 4 divided by 3 into 10 power minus 10. Okay, 7.5 by 3 must be 2.5 into 10 power 6. So 2.5 into 10 power 6, the answer is the third option. 177 answer is the right third option. Now 178 is the next one. Young's double slit experiment. Question is from second year topic, wave optics. Separation between coherent sources halved and distance between screen and slit doubled. Fringe width becomes. Everyone knows the formula for fringe width. Beta is equal to lambda capital D by small d. Lambda wavelength, capital D distance between slit and screen, small d distance between two slits. And capital D, what happened? Capital D doubled. See, capital T doubled and small d has made 1 by 2. So 2 by 1 by 2 would become 4. So the answer must be 4 times. Right answer is fourth option, 4 times. 178 answer 4. 179. The resistance wire connected to the left gap of meter bridge, another one from current electricity, 10 ohm resistance in right gap divides into bridge ratio 3:2 is that asked. We know the balancing condition P by Q equal to R by S. The unknown resistance may be X, then the resistance on the right arm is 10 is equal to the ratio of division is 3 by 2. So P by Q equal to R by S is written. From this, X is equal to 30 by 2, nothing but 15 ohm. So we got 15 ohm as the value of the unknown resistance. Okay, unknown resistance is that of 15 ohm, but 15 ohm means 1.5 meter because that wire on the left gap is given to be of 1.5 meter. 15 ohm has 1.5 meter. That means 1 ohm should have 1.5 divided by 15. That means 0.1. 0.1. The answer must be 1 into 10 power minus 1. Third option is the right answer. Third option is the right answer. 179. The last one is 180th one. It is that a ray is incident at an angle of incidence I on one surface of small angled prism with angle of prism A emerges normally from the opposite surface. Refractive index of that medium is mu. Then what angle of incidence it incidence? Okay, let that prism be this, the incident ray, the emergent ray goes like this. Normally it is given normal emergence. For normal emergence, here also that angle of incidence at the second surface is 0. So that the rays should be drawn like this. The normal at the first surface looks like this. Then the incident ray must be from rarer to denser, it should bend like this. So these are the arrow marks of that. Here, this is the angle of the small angle prism. This is the angle of incidence and mu is the refractive index of the prism. Here, this angle R2, second angle of refraction is 0 because that is normal incidence at the second surface. The first surface, this angle is R1. We know A is equal to R1 plus R2. A is equal to R1 plus R2. So R2 is 0. So A is equal to R1. This angle R1 is equal to A. Using Snell's law, the product of refractive index and sine of the angle, refractive index of air is 1 into sine of that angle, sine I, is equal to refractive index of the other medium, mu, sine of that angle, sine A. So sine functions can be cancelled from both sides. So I equal to mu A. Then the right answer is the fourth option. With that, the physics discussion is over. Hope that everybody is happy. Now you may have counted your marks. You are better. Best of luck. Now, thank you.